Welcome to another unit of the ISM exercise set Business Mathematics, this time with a unit on derivatives. Let's have a look at the exercise. Here we have calculate the first derivative of the following functions. And we have three functions, first one being logarithm of 1 plus the exponential function, second one logarithm times x to the power of 3, and the final one x times the logarithm of x minus the exponential function. Let's take it one at a time. So we start here with f von x being logarithm of 1 plus the exponential function. So we see there's one function, the exponential function, being applied to another function, which is 1 plus the exponential function. So this is a classical case of applying the chain rule. So we see here our inner function, the g, that's 1 plus the exponential function. So it doesn't matter if we write this as e to the power of x or exp of x, basically the same. And we need the derivative of this function here. So 1 derived for anything is 0, and the exponential function derived for x is again the exponential function. So this results in exp of x. Then we have the outer function, that's here the logarithm, and the logarithm derived is 1 divided by z. Then we have all the different parts together, so that we can just plug them together for our result, meaning we start with the derivative of g times the derivative of h, and instead of the z, we replace again the g. So we have exp of x times 1 divided by, and then it's again 1 plus exp of x. So here it looks as follows, and taken together reads as exponential function of x divided by 1 plus exponential function. This already concludes the first part of this exercise. In the second part, part B, we have the function f of x being equal to logarithm times x to the power of 3. So here we have two different functions which are multiplied with each other. So this is a classical case for the product rule. So we need to find out what the two parts are which are multiplied. So the left one here is the logarithm, the derivative of the logarithm, as we know from the exercise before, that's 1 by x. And the second part, here the h, that's x to the power of 3, and the derivative of x to the power of 3, that's 3x squared. Because the 3 we pull in front of this, and then we reduce it by 1, giving us 3x to the power of 2. Then we just have to again plug all of this together, meaning first we take the derivative of g, that's 1 by x, multiply this with h, that's x to the power of 3, plus, then we have g, that's ln of x, times the derivative of h, that's 3 times x to the power of 2. So here we have x to the power of 3 divided by x, which is basically x squared, plus logarithm of x times 3x squared. And here we see, in both cases, we have an x squared, so we can just factor this out, making our life a bit easier, our function a bit easier. So it's x squared times, in parentheses, 1 plus 3 ln x. Yeah, and this already concludes as well the second of the three functions. And the final one, the third one in part C, that was the function x times ln x minus exponential function. Here we see this is a bit more complex. So what we're going to do is work our way from the outer part to the more inner part. So first off, we have x times the ln. So here we see we multiply two functions, meaning we need the product rule here. For the second part, however, for whatever is in the ln, we need as well the chain rule. So we need first the product rule, and then the chain rule. If we start with the product rule, the first function on the left, that's g, that's here our x. X derived for x is 1. Then we have the function on the right, our h, that's the ln of x minus exponential function. Here we don't know directly the derivative. So here for this function we need to apply our chain rule. So again we need an inner and outer function. Here the inner function is called L, the outer function is called K. So our inner function is x minus exponential function. X derived for x is 1, and the exponential function derived for x is again the exponential function. So this here translates into the derivative of 1 minus x of x. Then we have the outer function. The outer function here is the ln, and the derivative of the ln is 1 by z. Then we can just get the derivative of h by just plugging together the part for L and K we have. So it's derivative of L, 1 minus exponential function, times derivative of K, 1 divided by, and instead of the z, we insert the original L. So we have 1 divided by x minus exponential function. We put this together. This reads as 1 minus exponential function divided by x minus exponential function. And this is the derivative of h. And having now as well the derivative of h, we can get our derivative of f. This is derivative of g, so 1 times h, so it's ln x minus exponential function, plus g, so x, times derivative of h, so x times 1 minus exponential function divided by x minus exponential function. Looks as the following part here. And we can just write this a little bit differently, but we cannot really shorten anything here. So well, it stays as given here. And that's then our derivative of the function f. Yeah, and this was the third and final part of this set of functions and exercises. And I hope you enjoyed listening to it. And if you want to see more exercises of this type, feel free to visit the rest of the exercise set or the corresponding playlist. I say goodbye and see you next time.